Right. First of all, I want to cancel all those things that I configured earlier. One is I went to the interface and I put priority. That priority I would like to remove first. Next, I would like to do it on all the device. Even here I put priority. Right. Next is I'm going to remove the neighbor that we manually configured. Okay. So now I should not see any neighborship. Show IP OSPF neighbor. Still I have C.
Sir.
Right. Show IP OSPF neighbor. I'm expecting this to vanish. Show run section router OSPF. Okay, there is no extra configuration. Show run interface serial 6/0. Other than OSPF, there is no other extra configuration. For a while, I would like to shut down this interface so that if something in the buffer will get refreshed. Okay. So 2 is fine. Let me check 3. Clean. And I would like to shut down this interface as well. Okay. What next? We are going to move to second network type called point to multipoint. What we have learned there is when I configure point to multipoint, the neighbor should be dynamically discovered. And then the priority on all the interface will be 0, so there won't be any DR by DR election. For this hub and spoke, this is the recommended. And all the neighbors should be in the same subnet it is. And the timer should be 10 and 120, sorry, 30 and 120. Let's check all these things. I'm starting from router 4. Router 4. Go under the interface, okay? Should go under the interface. IP OSPF network type. You see? Point to multi-point. I say no shutdown. After this, I would like to go and show you show IP OSPF interface serial 6/0. You will see as point to multi-point. The timer is 30 and 120. Now, show IP interface brief. I have brought the interface up. You can see the interface is up. Let's go to router 3. Meanwhile, I'll go to the Wireshark. Do I have Wireshark? Let's start Wireshark. This time, the multicast address will be in use. This is what I want to show. Right now, there is no packet because the interface is down. I am going to bring it up. And then I want to say to the interface IP OSPF network type point to multipoint. You will be seeing that these two guys forming neighbor because the multicast is allowed. All right, so the frame relay should come up first and then OSPF. So meanwhile, we'll go to the other routers. You see? Dynamically neighbor discover, otherwise this is not possible, right? So going to router 2 to do the same thing. Also on router 3. Over. Now you can expect neighbor between all these devices. Look at this, the multicast address 224.0.0.5. The previous network type you did not see any multicast packet. Now the frame relay is carrying your multicast. And you see the neighbor between router 1 and router 2, 4. Let's go to router 1. You got neighbor with all three. Show IP route OSPF. You saw OSPF, you're seeing that OSPF routes now available for all the loopbacks and remote sites. Go to a remote site. Show IP route OSPF. And if you notice here, see it is called point to multi-point. All next hop is router 1. That's why it's point to multi-point. So R2, if it wants to go to 444, it will go to this point. and get routed. So there is no need for full mesh because it can go through the hub. Whereas in the previous case, the next stop address to reach 4444 was 10.1.0.4. Now you see, without no struggle, you will be able to ping. See, you are pinging. If you check, it will go to the hub, and then the response comes. All of frame relay UDP. Ping, no? We did trace route, so it uses UDP. The next stop is using the ICMP. Right. So easy. You see, you need to know all these network types. Only then you will know which one fits where. What we have seen so far is the industry standard. You see, there is no DRBDR, show IP OSPF neighbor. There is no DRBDR, all a full mesh, full state. Show IP OSPF neighbor. All are in full state. There is no two-way. And see the priority, the default is 0. Even if you change priority, there is no use. There won't be any DRBDR election because it's point to multi-point. What next I'm going to do is, I'm going to shut down all these 4 ports that faces a frame relay and switch to the third mode. Third mode is point to multi-point, non-broadcast. I need to add one additional word to what I have configured already. I need to add one extra word. After that, when I unshut, there won't be any neighbor. Why? Again, multicast is not supported in this because it's non-broadcast point to multi-point. So we have to configure neighbors manually to have neighborship. Let's do this. Before that, do you want to verify anything here? Do you want to verify anything here? Anything that you want to verify, you can ask me. We have finished the second network type.
No, it's all good.
Okay. Arul?
No, sir.
Okay, so I'm shutting down those WAN facing ports. And I'll put the network type as point to multi-point non-broadcast. Okay, so let us do that. This is the command earlier I gave. Now I need to add non-broadcast to it. Let's verify. Do show run section. No need. Do show run interface serial 6/0. You see, point to multi-point non-broadcast. Focus. Point to multi-point non-broadcast. But if you check here, it will show only point to multi-point. Where? Show IP OSPF interface serial. Here it will simply say point to multi-point because it is according to the industry standard they have to do, so they have done it. Industry standard supports only point to multi-point and non-broadcast. But Cisco standard can include additional feature called non-broadcast. That is what we have added. So don't worry about, don't care about, don't think too much about, ignore this. Even though it's not showing non-broadcast here, it is still point to multi-point non-broadcast only. The timers are this. Now, I have not brought the interface up. Still, the interface is down. Let it be down for some time. Now we'll go to router 2 and say IP OSPF network type point to multi-point non-broadcast. Also on router 3. And also on router 4. Done. What is next? The next thing is we need to bring the interface up and see whether neighbor comes up. Interface will come up, but the neighbor won't come up. We know the reason, because neighbors need to be manually configured, and there won't be any DR/BDR. These are the two things we need to check. So I'm bringing the interface up on switch 4, switch 3, switch 2, right, no shutdown. I brought the interface up. I'm looking for neighbor, show IP OSPF neighbor, no neighbor. So what shall we do? We have to configure neighbor manually. Router OSPF 1, neighbor. Now what is the difference between the first one and this one? In this one there is no DR/BDR, so you no need to say priority 0. Nothing like that. 2, 3, 4. Okay. Likewise on R2. Neighbor 10.1.0.1. This I recommend on all sites, so I will paste it on 3 also. And as also on 4. And if you notice that there is no multicast involved here, all are point to point. Because it is point to multi-point on broadcast. And now neighbors are done. Let us go and verify. Go to R1. Show IP OSPF neighbor. Show, see there is no DR/BDR. Show IP route OSPF. You got the routes. Now let us go to router 2 and verify. And even here, you can see the next hop is 10.1.0.1. As a result, you will be able to ping now. Sorry, 2. I'm going between the spokes. Yeah? All right, the power has come. All right, so we have seen the 3 methods, which is very important. Now, 4th and 5th method is nothing. 4th method is you want, even though it's an NBMA, you want the timer to be 10 and 40. What is the timer right now? Show IP OSPF interface serial 6.
30 and 140, I think.
Yeah. Now, if you want 10 and 40, and if you want DR/BDR, then you can go and say network type as broadcast. And neighbors will be dynamically discovered. Let us go and do this. Interface serial 6/0 as usual. I shut. Okay. And I say IP OSPF network type broadcast. I'm not unshutting now because I want to remove the neighbors. Router OSPF 1. These neighbors I want to remove. Done. And then I'll go again and shut down that interface on R2. And change the network type as IP OSPF network type broadcast. All right, it is shut down. Yeah, it is shut down and then removed, and then neighbor I want to remove. I repeat this on R3 and on R4. Interface serial 6/0, shut down IP OSPF network type broadcast. All right. What you can expect is when I bring the interfaces up, the neighbors will be dynamically discovered, and the timers of the packet will be 10 and 40. The hello is 10. And then the multicast address will be involved. There will be DR BDR. As a result, the ping will not happen properly as we expect because there is no full mesh here. Okay. Now, then what is the difference between this one and the first one? Here the neighbors are dynamically discovered. There is one difference. Similarity, there is DR BDR in both. Similarity, both needs full mesh. Dissimilarity, timer. Let's now go and check it. No shit. All right. You will see neighbors coming up boom, 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 boom like that. Boom, boom, boom. Three boom. Three neighbors dynamically. Routes will be learned. Let's go and verify the interface first. Show IP OSPF interface serial 6/0. You can see the timer is changed to 10 and 40 even though it's a frame really. It behaves like a normal broadcast, but really it is not a normal broadcast. All right, the neighbor is still yet to come because the negotiation is going on. You can see that here. You see the multicast address involved. Now, yes, everything is good now. Everything looks good now. So let us go and verify. Look at this, three neighbors have come. Show IP OSPF neighbor. See, there will be DR BDR as I said. The one with the bigger route radius become DR. But because it is hub and spoke, the hello did not properly reach. So router 1 has become BDR. Don't expect a ping because it's not a full mesh. Show IP route OSPF, you don't see all routes. You only see routes to the DR's network.
So why do we need for pinging? Why do we need the full machine? Full machine? Because why do we use like switch in the middle? I mean the regular broadcast. We didn't do the full
No,
machine.
no.
Why we need?
Wait. When you say regular switch,
Yeah.
they're all in
Yeah.
single broadcast domain.
Yes.
This is not single broadcast. You have three different tunnels, VPN tunnels only. Only three tunnels connecting 1 to 2,
Oh yes, yes.
1
In
to
the
3,
different frame distribution.
1 to 4. That is why. Okay, now let's move on to the fourth one. Fifth one. Fifth one is point to point. For example, I have here 10.1.2, but here I have 20, and here I have 30. In that case, I need point to point in NVMe. Right, so again, let's go and shut down all those ports on all four devices and begin our new thing. Interface serial 6/0 shut down. When I say IP OSPF network type, IP OSPF network type point to point. Still the interface is down. Let me go to router 2. Wait, I'll do from here. Do show history. I'll copy this. I'll paste it on 2. 3 and 4. Alright, we have changed the network type. Now let us change the IP address. Here we want 30.1.0.4. Okay, next is I'll go to router 3. IP address is 20.1.0.3. And I'll go to router 2. Okay, router 2, leave it the same. Next, what I want to do is I want to go to router 1. Please focus, something very important is coming. On router 1, I'm going to create sub interface. Problem is the inverse ARP cannot work in sub interface. You remember initially I showed you inverse ARP. This one. Inverse ARP. INVERSEARP. Come on. No problem. I can see it here. I am. Okay, simply ARP is enough. This inverse ARP protocol cannot work on sub interface because it's not physical interface. No, this is going to be a sub interface. I'll go under interface serial 6/0. I'll remove the IP address. No IP address. I remove. If you want, you can check show IP interface brief. Here, no IP address. Administratively down. I'm going to now go interface serial 6/0.10 point to point. Very important. And I say IP address 10.1.0.1 255.255.0.0. This is a sub interface, so no need to say no shutdown. If you bring the physical interface up, the sub interface will come up. And again, I'm going to say another serial interface 20, IP address 20.1.0.1. Again 30.
Sir, IP address 20, right?
Thank you for reminding. 20, 20, 20. Right. Now let's verify these interface show IP interface brief. Look at this, we got the interface, but all are down because the physical is down. Interface serial 6/0, no shit. I also want to bring the interface up on other remote sites. Okay, done. Now, if you see, frame relay cannot work because it's a serial interface. As a result, if I type show frame relay map as earlier, I used to see something, but now nothing is coming. No discovery. What about on the router's 2 side? Router 2 is physical interface. Even router 2 still, it does not come, but it will come on router 2. There is no problem. Router 2, it will come. Once you fix on router 1 side, we need to fix it on router 1 side. Show RAN interface serial 6/0. Encapsulation frame relay is there. And it is point to point. Nice. .10, this is the configuration. What need to be done is you need to go to the sub interface and write a map. Frame relay map for IP protocol. In order to go to 10.1.0.2, use the DLC number 102. Broadcast. Actually, you no need to do this. Frame relay, because it's a point to point, I can say frame relay interface del C 102. This is enough. Likewise, I need to go to the another sub interface. One 103. Now, if you see show frame relay map, you will find these things are not dynamically given. These things are statically configured by us. See, it shows point to point. Now, if you go back to router 2 here, you got the map. This is dynamic. Here you don't see that word dynamic. We configured these things manually. Okay, what is next? Next is show IP OSPF neighbor. There is no neighbor. Show IP OSPF interface brief. We don't have OSPF running, so let us go to interface serial 6/0.10 IP OSPF 1 area 0. interface serial 6/0.20, interface serial 6/0.30. Now OSPF has come with multiple subnets. Show IP route OSPF. You got the roots. Show IP route OSPF neighbor. Show IP OSPF neighbor. You got the neighbor. See, all are point to point, so no DRBDR. Now let's go to router 2 and verify. You see, you got the roots. You can ping now. If this ping happens, you can ping 30 and 20 also, no? Otherwise, how you will ping to 4444 if you're not pinging 30? 30.1 dot different subnet, you're able to ping. You're able to ping. All right, so we have seen that all 5 NBMA network types, you need to take some time, analyze what you have learned, examine very well the differences. And in our Ethernet environment, if you wish to have one of this behavior in your network, you can pick the right type and go to the interface like this. IP OSPF network type. You can use any one of this. So this is not only available on serial, it is also available on Ethernet. Let me show you. You see, it's available on both Ethernet and serial. Any question?
No, nothing in here. This is all good from the network type. I think this is all good.
Wonderful. So once the video is ready,